Welcome back to the deep dive. Today, we are walking straight into the fire.
Oh yeah, we really are.
We're tackling the phase of the CPM AI framework that I think everyone assumes is going to be the fun part, the part where you get to feel like a wizard, but it turns out to be the absolute make or break point for the exam.
Yep.
We are talking about phase 4, model development.
It is the beast of the framework. You're absolutely right. People think this is the fun part because this is where you actually get to build the robot.
Right.
This is where the code runs. This is where the magic happens.
Exactly. I sat down this week thinking, okay, finally, no more abstract business understanding, no more tedious data cleaning. I'm going to train some models. I'm going to be a data scientist.
And then reality hit.
And then I hit the practice questions. And honestly,
Yeah.
I feel like I've been hit by a truck.
Well, that is the universal phase 4 experience. It's kind of the valley of despair before the enlightenment. What specifically is causing the headache for you?
It's the terminology. It feels like a shell game. I mean, I'm looking at scenarios where a model is broken, and to me, fixing it is optimization. If I make it work better, I am optimizing it.
Sure, in plain English, yes.
Right, but the answer key tells me, no, that's data engineering, go back to phase 2.
Ah.
Or I think I'm just, tweaking a test to be more accurate and the study guide screams contamination at me. I just feel like I'm tripping over invisible wires every time I take a step.
Yeah, you are tripping over the boundaries of the methodology. That's what phase CRE is really about. It isn't just coding.
Okay.
It is coding within strict constraints. If we can crack the logic of those constraints today, specifically the difference between tuning the engine and fixing the fuel, we're going to solve about 80% of the problems you're facing.
That is exactly what I need. I really want to slow this way down. We have the time. I don't want just the definitions because, I can read a glossary.
Right.
I want to understand the why. Why does the framework force us to go back to phase 2? Why is changing a metric considered cheating?
Yeah.
I want to argue about it a little bit because, frankly, some of it feels really counterintuitive to me.
I love that. We should argue about it. Because if you can defend the logic to me, you can pass the exam.
Sounds good.
So here's our roadmap for the listeners and for you. We're going to look at 3 specific task groups that trap people. Then we're going to do 3 deep concept dives where we dissect the logic. And finally, I'm going to put you through a rapid-fire gauntlet.
I am ready. But before we dive in, give me the high-level pitch. If phase I is the why and phase 2 is the what is phase 4 really?
Phase 4 is the how. But here's the catch. It is the execution of a blueprint that is already dried and stamped.
Okay.
Think of it like construction. Phase 4 is pouring the concrete. You are building the structure. If you're standing there with the cement mixer and you suddenly realize the foundation is the wrong shape.
You don't just pour more concrete to hide it.
Exactly. You have to stop the mixer.
Yeah.
You have to put down the shovel and go back to the architect's office.
Yeah.
That is the discipline.
I like that.
And specifically for today, we are focusing on the critical, high, and medium priority tasks. But mostly, we're focusing on the traps. And for everyone listening right now, I have a rule. You need to mentally pick an answer before every reveal. No passive listening today.
Okay, I like that image. I'm holding the shovel. Let's look at the first problem. You mentioned there are 3 terms that people constantly mix up. What's the first one?
The first one is a mouthful. It is the task formerly known as Select Cognitive Relevant Algorithm/Modeling Technique.
Right. And in my head, I translated that to decide to use AI.
And that right there is the first trap.
Really?
Yeah. Deciding to use AI happened weeks ago in phase I, when you did the business understanding. You don't even get to phase Hall V unless you've already decided AI is the solution.
Oh, right. Oh,
This task is different. This is about selecting the specific modality.
okay, so it's not are we traveling, it's are we taking a car, a plane, or a boat?
Precisely. It is like a surgeon choosing the right procedure before an operation. You don't just choose surgery. You choose open, laparoscopic, robotic. If you pick the wrong approach, the outcome is compromised from the start.
Got it.
And in the CPM AI framework, there are 5 very specific vehicles you can choose from. Can you name them?
Let me try. I know classical algorithms is one like regression, decision trees, the old school stuff.
That's 1. The workhorses?
Then there's ensemble methods where you mix them.
2.
AutoML.
3. And this is a big one these days. Using a platform to pick the model for you.
Okay, then there's using something that already exists, pre-trained models.
4. Specifically fine-tuning or retraining them.
And the new kid on the block, generative AI.
5. Those are your buckets. This task isn't just saying run the code. It is explicitly documenting which of those 5 paths you're taking and why.
Okay, I get that in theory, but why does this trip people up on the exam? It seems like a straightforward multiple choice question. Which one did they pick?
Because In the real world and in the exam scenarios, people don't just pick one and stay there. They drift.
What do you mean drift?
The trap is about what happens when you change your mind midstream.
Give me an example.
Let's look at a scenario from the stack. This is the financial services case based on source item 1, scenario B.
Okay, credit risk stuff.
Right. Imagine a team is building a credit risk model. They sit down, they look at the data, and they formally document. We are selecting a classical approach. We are going to use a gradient boosting classifier.
Solid choice. That's standard for credit risk. It's interpretable. It's robust.
Agreed. But then they start working. A senior data scientist looks at the early results and says, this is good, but it's a bit volatile.
Okay.
If we combine this gradient boosting model with a logistic regression model, we can smooth out the predictions across different customer segments.
So they're mixing two models together. One for the complex stuff, one for the baseline.
Right. Now, imagine a junior project manager steps in and says, whoa, stop. Our documentation says classical selection. You are now doing a combination. That invalidates the selection document.
Uh-oh.
The PM says, we need to stop, go back to the beginning of the task, and reevaluate the selection process.
I see the conflict. The scientist wants to build, but the PM wants to follow the rules.
Exactly.
Yeah.
So here is the question for you and for the listener. Does combining models require a new task, or does it fit under the current one?
I'm trying to apply the construction metaphor you gave me. If I said I'm building a brick house, and then I decide to add wood siding, I've changed the design.
Okay.
I feel like the PM is right. If you change the model, you change the selection. Right. You have to document the new decision as a new selection.
So you're saying they have to restart the task?
I think it's a new selection, yes. You moved from classical to something else.
You are incorrect.
Yeah.
And this is the ensemble trap.
Damn it.
All right.
Okay, explain.
When you combine models, you are moving into ensemble methods. But, and this is the key, ensemble methods is explicitly named as one of the options within that exact same task group.
Oh.
You aren't abandoning the select modeling technique task. You are just navigating within it. Deciding to combine models is a recognized technique within Phase 2, not a do-over.
So then a restart.
It's not a restart, it's a refinement. Ensemble is a valid selection strategy. The trap is thinking that selection implies picking just one single algorithm.
I see. I was thinking selection meant picking the one specific algorithm we're going to use forever. But you're saying selection means picking a broad strategy from the 5 buckets.
Exactly. If your strategy shifts from solo instrument to orchestra, you are still in the music selection phase. You don't have to cancel the concert. You just document that you are now using an ensemble approach.
Okay, that's a crucial distinction. Because if I restart the task, I'm wasting time and budget. If I just pivot to ensemble, I'm keeping momentum.
Correct. The framework allows for complexity.
Yeah.
It just demands you recognize what that complexity is. It's an ensemble. Document it as such and keep moving forward.
I need a memory hook for this one.
Try this. Ensemble is a valid selection, not a restart. Just because you added a second ingredient doesn't mean you have to throw out the soup.
So the trap is over-policing the data scientists when they just combine models. Ensemble is a valid selection, not a restart.
Okay, I've locked that in.
Good. Now, let's move to the second term.
Bring it on.
This one is the source of probably the most ethical failures in AI. Generate model test design.
That sounds incredibly boring, writing the test.
It sounds boring until you realize that if you do it wrong, you end up on the front page of the news for all the wrong reasons. The plain language explanation is this. You must document exactly how you will grade the model before you train it.
Emphasize before.
Strictly before.
But play devil's advocate with me here. In agile software development, we change acceptance criteria all the time. We build a feature, look at it, and say, actually, it needs to be faster. Why is AI so rigid?
Because AI is probabilistic, not deterministic. In standard software, if a button works, it works.
Right.
In AI, the model is making guesses. If you don't define what a good guess is beforehand, human nature will make you redefine good to match whatever the model actually did.
So it's about preventing us from lying to ourselves.
It is about preventing evaluation contamination. Think of a pharma company writing the clinical trial protocol.
Okay.
A company wants to release a new blood pressure drug. When do they write the definition of success? Do they write it before they give the pills to the patients or after?
Definitely before. They have to say, we need to see a 10% drop in blood pressure. If they did it after.
If they did it after, they could look at the data and say, well, blood pressure didn't go down.
Yeah.
But look, their hair grew back. Let's market it as a hair loss drug and call the trial a huge success.
That's fraud.
That is fraud, technically known as PA hacking or data dredging. And in AI, we call it evaluation contamination.
Okay, let's look at a scenario. I feel like I can spot this one now.
Don't get cocky. Here is the logistics company scenario based on source item 2.
Okay.
A team is building a route optimization model. They do everything right. They finish the test design. They set the metrics accuracy and speed.
So far, so good.
They train the model. Afterwards, they look at the results. The model is okay, but not amazing on accuracy.
Right.
However, the data scientist notices something interesting. The model is incredibly good at predicting arrival time reliability, something they didn't explicitly measure in the original plan.
Okay. So they stumbled on a new superpower.
Right. They propose adding a new metric area under the precision recall curve because it shows the model quality better. They aren't deleting the bad accuracy numbers. They're just adding this new metric to show the full picture.
The project manager has to decide.
Exactly. Is this a valid update to the test design, or is it a risk? Listeners, pick your answer.
Man, this is tough because they aren't hiding the bad news. They are just adding context. I mean, in the real world, I'd want to know that the model is good at reliability. That's valuable info.
Commit to an answer. Valid update or risk?
I want to say valid update. More metrics mean a better test, right? Who cares when we added it if it gives us better insight?
And you just failed the audit.
No way. Why?
It is a risk, specifically evaluation contamination.
But why? I'm not lying about the accuracy. I'm just adding something good.
You aren't lying, but you are shaping the target around the arrow. You shot the arrow, saw where it landed, and then drew a bullseye around it. Adding criteria after seeing results, even good criteria, means you are shaping the test to fit the model.
Wow.
The study guide says this should be completed before training begins. It's a best practice consistent with CPMAI evaluation planning.
So what should they do? Just ignore the finding?
No, you document the finding as an observation, but you cannot include it as a pass-fail success criterion for this cycle. You can use it to design the next version of the model, but you cannot retroactively say, our goal was high reliability, when that wasn't true when you started.
That is a harsh standard.
It has to be. Otherwise, every failed model becomes a success if you look hard enough for a random correlation. The trap is thinking, this is an optimization task. It's not. It's a test design integrity issue.
So the trap is treating the test design like a living document during phase 4.
Exactly. Post-training test design equals contamination. That's your memory hook.
Post-training test design equals contamination. Got it. The ticket window closes when the race starts. You can't bet on the winner after they cross the line.
Spot on. Ready for the third term.
I am 0 for 2 on the tricky ones. This is harder than I thought. Hit me.
The third term is the most technical and the most commonly misused. Hyperparameter optimization.
Okay, this is the tuning. This is where I struggle big time. I know parameters are the things inside the model, so hyperparameters are what? The super parameters.
Think of it this way. A model learns parameters from the data, like the weights in a neural network. You don't set those. The math sets them. Hyperparameters are the settings you choose before the learning starts. They control how the model learns, like adjusting the learning rate or the tree depth to squeeze out better performance.
Give me a metaphor for this one.
Think of a sound engineer in a recording studio. The band is the data. The song they play is the model. The sound engineer is at the mixing board.
Okay, I follow.
The engineer can adjust the bass, the treble, the reverb, the volume. Those knobs in the mixing board, those are hyperparameters. You are fine-tuning the balance after the tracks are laid down. They change the quality of the output, but they don't change the song itself.
Got it. The engineer can't make the drummer play a different beat. They can just make the beat sound punchier.
Exactly. Now keep that distinction in mind. Knobs versus musician. Here's the scenario. Based on source item 3, scenario B, manufacturing context.
Okay, factory robots or something.
Exactly. A team builds a predictive maintenance model for factory robots. The model underperforms, accuracy is at 75%, and they need 90.
A familiar story.
A data scientist says, I know how to fix this. I'm going to perform some tuning.
Sounds promising.
Their proposal is twofold. First, they want to change the training and test split ratio, say from 80-20 to 70-30.
Okay.
Second, they want to add 18 months of historical data from the archive.
Okay, so they are changing the split and adding more data.
The question is this a valid hyperparameter optimization decision?
I'm gun-shy now. But, I mean, if I add more data, the model learns better. Changing the data amount changes the parameters of the model. So yes, this is valid optimization.
You are incorrect again.
Come on, why?
Think back to the metaphor. The learning rate is a knob. with the data. The data is the band.
Oh,
If you add 18 months of history, you're bringing in a new drummer or giving them new sheet music.
I'm changing the source material.
Exactly.
Oh.
Data splits and time ranges originate in phase 2, data requirements.
Ah, phase 2.
You cannot tune your way out of bad data ingredients in phase 4. If you change the data split or add new data sources, you are no longer doing hyperparameter optimization. The correct action is to iterate back to phase 2.
So the trap is confusing tuning the model with changing the data scope.
Yes. The exam will try to trick you by putting valid hyperparameter moves next to invalid ones, or dressing up a data fix as an optimization task.
That is sneaky, because in real life, I'd probably just do both at the same time and call it a day.
In real life, maybe. But for the audit trail and the CPMAI exam, you are performing two totally different tasks. Hyperparameter optimization is phase 4. Changing data scope is phase 2.
Okay, I need a hook. Tuning is EQ. Data scope is the recording. If the recording is bad, go back.
Perfect. If the recording is bad, you can't EQ it into a hit. You have to record it again.
So the trap is thinking I can fix the data while I'm tuning the model.
Exactly. They belong to different phases.
It feels restrictive, but I guess it forces you to be deliberate.
It forces you to respect the dependencies. If you change the inputs, you change the requirements.
Wow, okay, I feel a lot better about the terms now. But you mentioned concepts. You called them logic puzzles earlier.
Yes. We're moving from definitions to the logic puzzles, the concepts. The terms are the what, but the concepts are the when and the why. We've touched on them, but I want to harden them into concrete rules you can use.
Let's do it. What's concept 1?
Concept 1 is test design precedes training. Sequencing is exam critical.
Now, I thought I understood this with the evaluation contamination thing, but I still don't get why I can't just adjust the test if I find something new, like class imbalance during training.
Because that destroys the validity of the test.
But if the data is skewed, the test is unfair anyway.
Let's use a metaphor. The teacher in the exam.
Okay.
Imagine a teacher. The teacher writes a final exam. Then the teacher grades the homework over the semester and realizes, oh no, this student is terrible at algebra, but they're great at geometry.
Okay, I see where this is going.
So the teacher decides, I want the student to pass. I'm going to rewrite the final exam to be 90% geometry and only 10% algebra.
Yeah, that's rigging the grade. You aren't measuring learning, you're reverse engineering a passing grade.
Exactly. Now let's look at a hard scenario. Source item 4, scenario B telecom.
Okay.
A team is building a churn prediction model, trying to guess who will cancel their phone plan. Test design is done, the precision target is met, but the recall is too low.
So it's missing a lot of the actual churners.
Right. The scientist argues the recall threshold was set too high because we didn't know about the class imbalance. There are hardly any churners in this data set. Let's lower the threshold now to reflect reality.
Okay, let me walk through this out loud.
Go ahead.
Class imbalance is a real thing. It ruins models. So the scientist is right that the threshold was probably wrong to begin with.
Okay.
But if I change it now after the model failed, I'm just lowering the bar so the model passes.
Oh,
I'm the teacher rewriting the exam.
and your conclusion.
They can't do it.
Correct. Yeah, you nailed it. The logic here is that class imbalance is a phase 2 data quality issue. It is not a justification for a post-training test design revision.
So what's the contrast summary for this one?
Test design happens before training. Never reverse the order.
Even if you have a really good statistically sound reason.
The timing invalidates the reason. If the data is imbalanced, go back to phase 2 and fix the data, or start a new test design cycle. But don't slide the threshold down quietly in phase 4.
Test design happens before training. Never reverse the order. Got it. What is concept 2?
Concept 2. Algorithm selection is AI-specific and broad.
Now, I thought selection meant we pick the winner, but the study guide lists 5 things, and we talked about the ensemble trap earlier.
Right. The selection task group covers the evaluation of these approaches.
Give me a metaphor for this one.
The civil engineer and the bridge.
Okay.
You're a project manager. A client says, build me a bridge. You don't just say, all right, suspension bridge, let's go.
Right. You'd evaluate the terrain.
You select between suspension, arch, beam.
Hmm.
The selection is the process of choosing the design that fits the terrain.
Okay.
Let's look at a hard scenario for this. Based on source item 5, scenario B retail inventory.
Let's hear it.
You have 3 team members proposing 3 different things for an inventory model. Scientist A wants gradient boosting, which is classical. Scientist B wants a combination, an ensemble. Scientist C wants to use an AutoML platform.
A classic team argument.
Exactly. So here's the question. How does the project manager frame this? Does the PM have to pick one before entering the task?
Walk me through it.
Imagine the PM saying, we can't start the select modeling technique task until we decide which of these three we're using.
Wait, no, the task is selecting. So the PM doesn't pick beforehand. The PM documents the decision process across all three options. The evaluation is the task.
Correct. You got it.
Really? Awesome.
Select modeling technique task group explicitly covers classical, ensemble, and AutoML. You don't arbitrate the winner before the race. The race is the task.
So the contrast summary here is, selection isn't a single choice. It's the process of choosing the right tool from 5 options.
Exactly. Selection isn't a single choice. It's the process of choosing the right tool from 5 options.
Yeah.
Never mix up the final decision with the process of deciding.
I love that. It takes the pressure off having the perfect answer on day 1.
All right, concept 3. Phase 4 executes against Phase 2 data requirements.
This is the one I failed earlier, the back to Phase 2 thing.
Yes. The chef and the recipe.
Oh, I'm ready for a food metaphor.
Phase 4 is the kitchen. Phase 2 is the grocery store and the recipe.
Okay.
If the recipe called for the wrong flour, the chef cannot fix it by adding more salt. That's tuning. They have to go back to the recipe author.
Because the ingredients are fundamentally wrong.
Right. Let's look at a hard scenario. Source item 6, scenario B, healthcare.
Okay.
Hyperparameter optimization is done. The model still fails on real-world data. The lead scientist digs in and finds temporal leakage. It means recent claims from the same patient are in both the training set and the test set.
Oh, so the model saw the answer key.
Exactly. The debate is this. Is fixing the train test split a Phase 4 tuning fix or a Phase 2 iteration?
Okay, let me think. Leakage means the data was split randomly instead of by time.
Yes.
And splitting the data happens in Phase 2, data preparation, so we have to iterate back.
Correct again.
It's not tuning because we aren't adjusting the model settings. We are changing the definition of the data itself.
Spot on. Resplitting data is not hyperparameter optimization. It's correcting the training and test data requirements from Phase 2.
So the contrast summary is, Concept A, tuning adjusts settings. Concept B, data requirements, sets the ingredients. If ingredients are wrong, go back.
Exactly. Never mix them. Tuning adjusts settings, data requirements, set ingredients.
This is making so much more sense now. I'm actually seeing the matrix here.
It's just boundaries. Once you see the walls, you stop running into them.
True.
All right, you've survived the deep dives. Are you ready for the rapid fire segment?
Oh boy. Bring it on. Let's do it.
Format is simple. I fire 4 short scenarios. You answer each in one sentence.
Okay.
Scenario 1. A healthcare team starts training a CNN, a convolutional neural network, immediately, without documenting why they didn't look at other approaches. Based on source item 1, scenario A.
Failed task. Select cognitive relevant algorithm. You have to document the selection.
Correct. Scenario 2. A PM asks to define evaluation metrics after seeing the holdout set results. Source item 2, scenario A.
Failed concept. Evaluation contamination. Test design must precede training.
Correct. Scenario 3. A retail model validation is low. The team adjusts the learning rate and tree depth. Source item 3, scenario A.
Correct task. Hyperparameter optimization. That's turning the knobs.
Correct. That is a valid Phase 4 move. Scenario 4. A bank model struggles with new patterns. The team wants to extend the data window by 6 months. Source item 6, scenario A.
Incorrect phase. They must iterate back to Phase 2 because that's a data requirement.
Correct. 4 for 4.
Yes.
Right.
Oh man, that feels so much better than the beginning of this session.
You've got the logic down now.
I really do. I mean, before today, I genuinely thought fixing the data split was just part of tuning the model.
Sure.
Now I know that hyperparameter optimization is strictly for settings, and data splits belong to Phase 2.
Huge distinction.
And I also realized that test design has to happen before I even touch the run button on training or I'm contaminating the results. I was definitely falling for the agile trap there.
It's the most common trap for software devs moving into AI.
Well, this has been incredibly helpful.
I'm glad. Let me leave you with one final anchor for the most exam-critical item in this phase.
Lay it on me.
Test design precedes training. If you see a scenario where they define success after seeing the result, it is wrong every single time.
I'll remember that. I'm writing it on a Post-it note right now.
Good. And for everyone listening, remember our sign-off rule. Pick your answer before the reveal every time.
Pick your answer before the reveal every time.
Thanks for joining us on this deep dive. Catch you on the next one.